Hello, everyone. Hello, everyone. How's your day? How's your days going? Hope they're going well. They're going well. I guess we're doing. Oh. How do Yeah. So. Second. Yeah. So you should be able to hopefully see my screen and the two things on my screen right now. Let me just check in to see how it looks. Um. Screen and the two things on my screen right now. But I don't know how I can really fix that. Let me just check in to see. Oh, I do know how I can fix that. Oh, okay, okay. Yeah, no, I can do this. Just put this on top, and then I can make these a little. Well, make this like that big, and I can make this about, say, yay big. Let me increase this a little bit. Decrease this thing a little bit so it fits. It's decent, I guess. It's a little bit hard to do, I guess, to organize it completely perfectly, but I think if anything, you guys want to see my code a little bit more. Like, I have it organized the same way when I'm actually doing this. I'm not sure what the best way to organize it would be, because I want you to be able to read the article, or read the book, at least reference it reasonably well, but also be able to, to see my code. I'm not sure. I think this is a little bit better, so it should be This is an improvement for sure. Okay, so I guess we can move on to this problem. So we're implementing the Cartesian product right here. So we're creating a hmm. The last one felt intuitive on why the implementation worked, but so if I was doing this, I would just iterate through all the arrays, or I'd get the length of the arrays, and then for each array, I'd check the things, and if it's not equal to one that we've already seen, then I'd add it, or else I wouldn't. But this seems like there's a more efficient way to do it. So you create an array that will contain all the points in the Cartesian product. So I suppose that's pretty simple. Points is equal to, boom, we've done that exactly. Um, let's just quickly. Yeah, if Justin Skycak ever sees this, I think that's how it's pronounced. Thank you for making this book. Pretty interesting. So you create a copy of points. Obviously you're getting the ranges. Wait, what? Um, well, we did the Cartesian product wrong. Okay, so it does A. Oh, I understand what it does now. Okay, so I was misunderstanding how it works. But basically, it just says A. It's one, always puts it. If it's two, it tries an option with all of them. Probably do this with like a bunch of for loops. Um, but let's see how we could do it. So you take the ranges, right? Take that as an input, and this could be as many as you want. But so you loop through range A. pack. Okay, so item one is gonna be. Whoa. Okay. So I suppose we should import a copy for this so we can deep copy. We're using a virtual environment. Probably, I don't think we are here. Just make sure we have copy. What? Oh, why is it on Thon? Get out of Python. Get to normal. Yeah, okay. Good. And maybe just button copy. Oh no, no. Control C. Okay. Python. Pip install copy. See if it's already there. Should say if it's already there. Oh, is it already? Is it one of the ones we already have? Anyway, I think we have. It doesn't raise an import error, so it should be fine. Um. Well, okay. So I need to try to understand this. So it goes through the items through range, right? So I guess we could just go through step by step. So in ranges, right? Uh yeah. So it loops. It goes through all the things in ranges. Okay. So we have a range, right? Let's just think about how we do this. Um. Well, we need about six different A's. But if there's two of these, we need six times. So we do tons of lens. So we do, let's example, if there's three, for an example of this example, we'd need 1 times 3 times 2 A's. Yeah, you want, yeah. So you could find that, append that many A's, like that, and then you could add on more as you did the next ones. Um, but that seems really inefficient. Let's see the more elegant way that they've done it. So they've taken this. Yeah, I understand how to do it. I'm just not exactly sure how exactly it's implemented. Yeah, we're supposed to write tests too, but okay. You know what? Okay, we'll just do it the way that we would intuitively do it. So, um, okay, so first we need to say for in len ranges. I still don't understand the thing they're doing. So they're created points, right? We've done that. We've created a points variable. Looping through range A. tempted to do this with classes. There's no reason to do that. There's much elegant, but okay, we'll read through this again. Okay. What's this in Python? Why is it saying array? Right? Oh, it's Jason Skycak. Why did I say Justin? Man, I've been making some serious typos. Yeah, Python. Yeah, that's kind of weird. They want a yeah, gradient descent. We could do that, but um, okay. So not sure, not sure here. Honestly, not too sure how to do this, but okay, we create a copy of points, so we can do that. Let's just go step by step. So copy dot deep um, deep copy points. So copy of points is equal to this, right? So we've created a copy. So for I in uh, copy points, copy points, copy points. So boom. All right. Um. All right. Yeah. So we need to for each copy point loop through the first range, right? So for let's say point in the range, we need to loop through. Oops. Man. Okay. There we go. And then we need to make this point. So each point we need to loop through it. So so for in point, well, if it's just one, appending a range item. So copy of points. Appending a range item. I don't really understand what this is, so. Okay, so we have the ranges, the points. Cool, we have the ranges, we have the points. So it loops through range A. So for. Oh, wait, what are we doing? Well, in ranges, right? It loops through the ranges, not the points. Okay, yeah, so for range and ranges, so we need to loop through the range, I guess. So for item in range, right? So looks like we're appending. Why was this copy even needed then? So we're appending. What are we appending? A range item. So are we appending a range? I don't quite understand why this would work. So points equal. So what are the copies even needed? What are we copying? We do this whole thing and range the length of um, the length of the what points? I don't know. Okay, I guess return points. Let's just like we just print. Copy this. So it's fine. Just leave that ranges for now. We can change ranges later, but why do we name it range? See if this works. This definitely doesn't work. Let's see what this will return. Return exactly the equal same thing when I was saying equal. Right, yeah. So Uh, okay, I don't quite understand what this is saying. So what I'm gonna do is okay, I'm just gonna, oh, okay. I understand what it's trying to do now. Alright, we can do this, definitely. Easy. It's easy. It was very easy, I just didn't quite understand it. Um, so, how I understand it is in points, right? So, at the start, we look through the points. Um, okay, so starting, we, uh, we have the points, and we do, and, okay, so for each item in ranges, right, you have to take, um, you have to look at the stuff in points, right? So these are all the stuff in points. Um, um, so we're already iterating through. Yeah, so we just need to do for item in underscore. This is getting kind of complicated. Tons of for loops here. But it's good for working with arrays, I guess. So we're already doing so for blank and ranges, for I in points, what's points? Points is points is that array right there. For item in each item, um we're extending it and we're adding it. Um, uh, or uh, we're doing is I plus item. Assuming they're all arrays, right? So, oh, they might not be, so just make that an array. This is very unelegant, I suppose, but just need to see if it works first. Okay, so extended point is equal to that, and then we need to append extended points to uh, copy points. Extended point, and then at the end, we need to basically say points equal to copy points. I was going to throw an error. It's definitely going to throw an error. I don't know why yet, though. Dude. Get out of Python. Oh, that's pretty simple. I could have done that before. Well, this is rather slow. Oh, this is very slow. I think something's going wrong if it's taking this long. Okay, you know what? Let's just keep it simple, first of all. Let's print all the extended points and let's change the range so it's just two things. So just all these. Not even this. This should be done very quickly, but let's just check if the extended points are being added. Keyboard. This might be a slight problem. Oh, oops. We're using the variable before we define it. That's why that causes a fun error. Okay. Huh. Alright, so it's obviously doing something wrong. So it's getting it kind of right. What is it? 2, 3. Okay, yeah, it's just getting it wrong straight up. It's just straight up just wrong, right? It's just wrong. So, but the idea is a little bit better. I think. That's why it's taking so long, enormously long. Okay. Um. Okay. Um. So let's try a different approach. So we're here, right? So let's make the new points or extended points. Sorry. Uh, be equal to a empty array now. Um. So we've created a copy of the points. Um, oh yeah, we don't want to make that error again. We need to thing range. So we append R. But there's a slight problem here. Instead of doing range here, we need to do something different. So it needs to be item in R, which is for R in range here. In ranges for item in R. Right, so we need to append the item. So right now, for example, let's run it through real quick. So new point is going to be just a blank thing. We're going to append the item. An item is going to be so it's just going to be the normal array then. Um, I'm stupid. For some reason I thought this would work, but I just it's clearly not going to work. Um, I thought then, yeah, no. Yeah, this is obviously not going to work. Yeah, let's return this to see like what it's returning at this point. Oh yeah, the return is inside here, so it returns early. Oops, that shouldn't be returning early. What the fuck? Why does this even work? What? No, no, no. Whoa, 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 whoa. What, dude? need to clean my glasses soon. Okay. So we take the points, right? It's currently nothing. So for R and ranges, right? So this will, for example, let's say we're on the first one, it goes to A, right? And then it's like extended points. That's just a normal list. Now for point in points. So right now there's nothing in it, right? So it's just one thing. And for item in the range, A, new point is going to be a list of A, which is just going to be A. It's going to append the item to the new point. But I don't understand, why doesn't it just append all the item in the range? Oh yeah, we're doing the zeroth example right now, right? Okay, so point is gonna be nothing, is right now range for R and ranges, right? So we're doing just A. Okay, this works, but okay, let's say point's now A, right? So for R in ranges, we're done with this one. So it goes to the second range, right? 1, 2, 3. And now for point in points, A. Uh, oh, I understand. This was so kind of cool. Okay. Um, yeah, let's low key just read a little bit. Um, yeah, it's fine. I just want to see where this guy is now. You want to see where is this guy now? Ooh, damn. Damn. Let's see where Benjamin Park is. God dang, bro, these guys are all like cracked. Is it Sky? Oh. Oh, you guys can't see my screen. Damn. This Mateo Pass, bro, is cracked though. Let's check out Riley Paddock. He's probably reasonably cracked. Yeah. 2022. Pretty cracked. Pretty cool. All right. Yeah, you guys want to see something I've been kind of working on. Yes, here. Pi Show. I've been trying to make my own Pi Show version. Readable code. The linter still doesn't like me. Apparently this line's too long. Yeah, the linter still does not like me. Apparently house is too long. I've already changed it. It should only be one. Fine, there. Fine. Assume this is the main fender now. There's no way that's 126. Is that actually? How much more should it be? Okay, fine. There. There's no way this is 166 line. It's big. So speaking of, I've been needs on wait, extensions, right? Extensions. Extensions? Oh no, oh, testing. Figure Python test. Venv. I guess we'll figure out how to do that, but extensions, yeah. Oh, that's the button. Alright, let's do Vim. Do we have this right? Yeah. Can you come down a little bit? Okay, thanks. If you want to go from insert mode to normal, you have to put JF. Okay, from insert to visual, JV. Why is mine in insert right now? Yeah, so maybe I have to be in. Like, oh, I am visual. Okay, let's see. Can we X this off out? So we can't insert a space. Well, look, you scroll down, we still got spaces. Okay, so you have to get like the timing really right. Oh, I forgot how to go back from visual. Visual should be V, shouldn't it? Seems like really logical. From visual to insert, you just do I. Oh, caps lock I. Is that the same as shift I? It seems so. Visual to normal. Let's go from visual to normal. V. Okay. Wait, visual to normal is V? Why is it normal? Feels more like normal to visual should be V. Okay. Okay, kind of cool, I guess. Let's go back. Now, I just want to go from visual to. I just want to go to visual to insert again. So let's go from visual to insert. That's capital I. So let's turn on caps lock. Or, yeah, that did it. Apparently JV. Visual. Oh, capital I. Insert. Huh, kind of cool. Okay, anyway, so yeah, so specifically Pi show board, the way I've initialized is a 19 by 19 grid, right? Because Pi show, right? Pi show is basically an 18 by 18 grid. But you play on the intersections, right? Let me just pull up something. Yeah, right here, right? So this is 16. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Yeah, so it's 18 by 18 grid, but some of this is cut off. So basically there's an 18 by 18 grid. So I've added these points in. These points aren't actually there. Just insert them as basically points you can't go on, just for thing purposes. And then I basically just make sure the red points are categorized as red because certain tiles can't move there. I've kept the neutral points as 0. The other points as the white points as 2, I believe. Yeah, white points is um yeah, white is 2. I should put a semicolon and just make. Oh, oops. Did not mean to do that. Yeah. Anyway, so yeah, so that's that. So you want to see. So then I added a quick plot board, so it just plots the board so you can see it visually. Um, it's pretty simple. So it plots the board, but so it prints out the board here, right? So as you see, the twos form the triangle. That's the red triangle or the white triangle, and see it forms the same thing here. And these are the actual playable points where only white tiles can go. But these points are still neutral, so that's why they're still black. These tiles are obviously unplayable. That's why they're not even colored in. Um, and then I've added in these triangles and still shown the normal heat maps of where the normal tiles can, only white tiles can go. Right, compare that to this. Pretty decently similar. Obviously, it's not circular here, but it's enough for like a simple thing. And it's stored as a list of lists. And then what I was going to do is I was going to try to create the game environment for tracking the state. So I've imported the board, and I was going to create the host pieces, the guest pieces, but I realized that you need to keep track of the um who plays first. Oh, the guest plays first. So I should probably make this guest to play. That's the unfortunate part of this because you have to code that into the environment. So whenever you guest place, its host is automatic. It's still guest turn. I'm just gonna make it so that's not actually a turn, and we have to create. So a couple things we have to create. First of all, a class called PyShow tile. Got some underscores there. It's just readable. Yeah, PyShow tile, right? And then, oops, let's just make this pass. Um, close that. Okay. Yeah, so all our PyShow tiles, and this is going to be the environment for the actual game, and then we create subclasses, right? How do we do this class? Super or something like that. It's like inheritance in Python. I need to read up more on it, but I'm pretty sure it's like super dot something. Oh, or I could just do that. I thought you had to do super dot in it. Yeah, we. Yeah, I thought the way I've always done it is a super dot init method. Yeah, but that's what we're gonna do, I think. And the main problem is, let's say I put a piece here, right? Right. I think that's probably. Well, we could go on. I guess this is. We've done the Cartesian production. We could do some tests, but I think this is reasonably good for now. So I guess we're doing some searching and sorting algorithms next. Um, Wait, can I just check the parts again? So we have to work through searching and sorting, right? I'd say objects, whoa, overfitting, naive Bayes, phi graphs, and then gates. Wait, let's just see. Yeah, so this is something to work through. So I think we need to start going through this rather speedily. But I'm gonna take a break, I think, and then come back to this with some renewed energy. But I'm glad now I can finally close this, close off practice chapter one. That's supposed to be. Yep. So we finished chapter one. I think we learned a decent bit, mainly the testing strategies. It's the main thing we learned. Some we also learned about I guess Cartesian multiplication. I was just we're working on this though. It's not like particularly important, but yeah, I think that's pretty much it for now. Thank you guys for watching and listening along.